Today, what we're going to do is we're going to learn how to solve polynomial equations of any order, any size polynomials. So far, we've restricted ourselves to linears, quadratics, and cubics, x to the third power. After today, you should be able to do any size polynomial whatsoever. Find out what the factors are. The factors are the zeros. The zeros are the x-intercepts, the solutions. So to begin, long division. From elementary school, let's say 3. Just keep it easy. If we have a division problem like this, we can rewrite it as that. And once you do that, so we look at what times 3 equals 3. So 3 goes into 3 once. Then we take this 1, multiply it by 3, you get there. Then what do? Remember your division rules? We subtract them. And then anything else, put a 0 behind it. That's all we're doing now with the first column. When we add them, the first numbers disappear. They have to disappear. 5 minus 0 is 5. Repeat the process. What times 3 equals 5? Or how many times does 3 go into 5? Once. So 1 times 3 equals 3. Subtract them. Since 3 doesn't go into 2, that's our remainder. So the answer to our original question equals 11 plus a remainder of 2. 2 over 3, because it's a fractional remainder. That's how we did it. That's how we learned fractions and division back in elementary school. But thanks to calculators, you forgot that. This would be very important to review it because we're going to do this now with polynomials. For example, x squared plus 5x plus 6 divided by x over x plus 2. So they both look the same. We rewrote it this way. So whatever's on the bottom goes there. Whatever's on top goes inside the divisor. Now with polynomials, always look at the leading terms. You're interested in that. So what times x gives me x squared? X. So that goes up here. Same thing here. Is how many times 3 go into 3? Once. Once we did that, we took this number and multiplied it to that. Put it down there. So do the same thing here. X times x is x squared. X times 2 is positive 2x. Okay, now we got this number here. We change the signs and add. That's what we did here. It used to be 3. We changed the sign and we added the numbers. 3 plus negative 3 is 0. So we change the signs and we add. the first term should always disappear. If it doesn't, you did something wrong. Now see what we have left. 5 minus 2 is 3x, and bring down everything else. Repeat the process. Look at the leading terms. What times x gives me 3x? 3. A positive 3. So we do a positive 3. Signs are important. If that was a negative, we have to put a negative 3 up there. So we take this number. Positive 3 times x is positive 3x. Positive 3 times positive 2 is positive 6. Change the signs and add. The first term cancels, and so does the second one. So the remainder is 0. Which means this thing on top is called the quotient. That's your answer to this equation. So the quotient is the answer. Here's an important observation. If the remainder equals 0, then your denominator is a factor of the numerator. That's the remainder theorem. When you do division, if the remainder is 0, then whatever's on the bottom is a factor of what's on top. And that's the answer. The quotient is also a factor. In this case, if the remainder is 0, the denominator is a quotient, is the factor of. So is the quotient the answer. So far, so good. So this is what it looks like. You have a polynomial. It's called polynomial 1. It's some polynomial divided by another polynomial. When you do a division of polynomials, you're always going to end up with two things. The quotient and remember, I put this as a function because notice the answer is a function of x plus r of x, which is your remainder. The remainder can be 0 or something else. So this is the remainder theorem. Let's look at some more examples here. So looking at this, remember, the main polynomial is your numerator. What's the degree of your polynomial of P of X? Yeah, the degree is 3. What does that mean? What does degree 3 mean? No, that's multiplicities. Good try though. Degree 3 means we're going to have 3 solutions. That means we're going to have 3 X-intercepts. And that means we're going to have 3 factors. Remember, solutions, intercepts, factors, those are all the same thing, just written differently. So let's begin. We have this polynomial. So we're going to do long division. Very important note. If a variable term is missing, then place a 0 in that location. In other words, if we didn't have an x squared in this equation, I'd put a 0 x squared. So if we didn't have an x squared, I'd put a 0 because I have to have all the columns allocated. You notice also make sure that your powers are in decreasing order. Always do that first. Make sure equation highest exponent down to the constant. So what do I do first? Look at the leading terms. What times x gives me x cubed? We have 1x here. How many more do we need? Yep, we need 2 more x's, so x squared. Because this term, this which you put up here, times this first one have to equal this first term. So x squared times x is x cubed. X squared times 3 is positive 3x squared. Next step, we have to change the signs. And add. Remember, the first term should always disappear. If it doesn't, you did something wrong. So 2 minus 3 is negative 1 x squared. Bring down everything else. Repeat the process. First terms. What times x gives me negative x squared? Negative x. Because yeah, I'm missing 1 more x, and it has to change sign. So I'm missing a negative x. So I take this whole negative x and multiply it to both of these. So negative x times x is negative x squared. Negative x times positive 3 is negative 3x. Change signs. and add. The first terms cancel. -5 plus 3, since 5 is bigger, it's -2. Bring down what's left. And repeat the process. First terms, what times x gives me -2x? -2. So take -2 times x gives me -2x. -2 times +3 is -6. Change the signs and add. So what do we know? Yeah, x plus 3 is a factor of that numerator. What we know is that since its remainder is 0, that our polynomial has an x plus 3 as a factor. And what goes in the other parenthesis? The quotient. So okay, remember, we had this from the last page. This is the general rule. If the remainder is 0, we just have this. If we multiply this term to both sides, those cancel. So what we have the original polynomial and its factored forms. So this is our objective in this section of the course, is we have to now look for any numbers that give us a remainder of 0. If we have a remainder of 0, we know it's a factor. So that's our first factor. Look at this. It's a quadratic equation. Can we factor that? Look at the middle term. That's x. That goes in the first spaces. The second sign's a minus. That says it's different. One's plus and one's minus. What times what is 2? When you subtract it, you get 1. Yeah, 2 times 1 is 2. 2 minus 1 is 1. Since the first sign's a negative, the bigger number goes there. There you have it. You now have the 3 factors that make up this polynomial. We're supposed to have 3 of them. Bam, there they are. That's the objective of today. So my zeros are what? What are my x-intercepts? Yeah, it's always the opposite of what's inside there. So that's where we put a dot on our x-axis, and now we know the graph. It's cubic, so both ends point different directions. It's positive, so the right end goes up, left end goes down. So you see, we're building the graph in our head. Is 5 a solution? What's that polynomial? For x to the 4th minus 26x squared plus 25. Not a solution. Oh, or I can say a solution or 0. Is 5 a 0 of this polynomial? Okay, now it all depends on how you set this one up. What's your denominator? Because the way you check if it's a solution or a 0, you got to take your polynomial and divide it by what? We need an equation, remember? So we need an equation to get rid of the x's. Well, since we know x equals 5, right? That's a solution, that's a 0. If we subtract 5 from both sides, we got x minus 5. Okay, now you have to be very careful. What goes inside the dividing thing? X to the 4th, 0 x cubes minus 26x squared plus 0x plus 25. We're missing x cubed next the x, so we have to put them in there with 0 coefficients. Let's begin. What times x gives me x to the 4th? X cubed. Whatever we put there, we now multiply it to both of those. X cubed times x is x to the 4th. X cubed times negative 5 is negative 5x cubed. Change the signs and add. First term disappears. 0 plus 5 is 5x cubed. Bring down everything else. Minus 26x squared plus 0x plus 25. What's my next number? So what times x gives me 5x cubed? Yeah, positive 5x squared. Okay. Here's a shortcut. Remember, we're always asking, what does that need to multiply to that? So if I take 5x cubed and divide it by x, what do I have left? I cancel one of the x's. So that's where I get 5x squared. So 5x squared times x is 5x cubed. 5x squared times negative 5, positive times negative is negative. 5 times 5 is 25. X squared. Change the signs and add. The 5's cancel. Negative 26 plus 25 is negative 1x squared. Bring down everything else. What times x gives me negative x squared? Yep, negative x, very good. So negative x times x gives me negative x squared. Negative x times negative 5, negative is a positive, 5x. Change the signs and add. First terms disappear. 0 minus 5x is minus 5x. Bring down to 25. What times x gives me negative 5x? Negative 5. Has to be negative. So negative 5 times x is negative 5x. Negative 5 times negative 5 is positive 25. Change the signs and add. So is 5 a solution? Yes. 5 is a solution, therefore x minus 5 is a factor. So is that. These two are factors of this big one. There's another way you can check if it's a solution. This one's pretty big right now, so we won't use that one. We'll use the one we used earlier. Let's look at that one. This is method number 2. To check if a value is a 0 of a polynomial. Method 2, to check if a value, a number, is a 0 of a polynomial. So, is negative 2 a 0 of x squared plus 5x plus 6? Remember, this is what P of x is. Okay. Okay, don't do anything yet because I'm gonna show you another method. This is method number 2. If this is a 0, plug it in the equation. Negative 2 squared plus 5 times negative 2 plus 6. Anywhere I see an x, I put a negative 2 in there. negative 2 squared, negative 2 times negative 2 is positive 4. Negative times positive is negative. 5 times 2 is 10. Plus 6. 4 plus 6 is 10. Minus 10 equals 0. So you see what just happened there? If you take the 0 of a function, or the value of the denominator, solution of the denominator, and plug it in the equation, that's what you get. Let's try another one. Let's do this one. So let's do long division first. Let's check it out. X squared plus 5x plus 6. X times what is x squared? That's x. So x times x is x squared. X times 1 is 1x. Change the signs. And add. Let's cancel. 5 minus 1 is 4x. Bring down what's left. Repeat the process. What times x gives me 4x? A positive 4, right? So positive 4 times x is positive 4x. Positive 4 times 1 is positive 4. Change the signs and add. First term cancels. 6 minus 4 is 2. So is x plus 1 a factor? No. No, it's not. But let's do this also. If we take the denominator and solve it, what does it become? X minus 1. If we take this minus 1 and put it everywhere in the numerator, let's see what happens. Negative 1 squared is 1. Positive times negative is negative. 5 times 1 is 5. And positive 6. 1 plus 6 is 7. Minus 2, 5 is 2. That's an interesting way of looking at it. If whatever the remainder is the same as the result if I plug that denominator in there. I just thought that's pretty interesting. So you see the process that we're going to be using here to find factors of a polynomial. Find all of the denominators that equal 0, and whatever they are, those are our factors. Let me show you a shortcut. synthetic division. Synthetic division, first off, only works if the denominator is of the form x plus or minus some number. It's got to be a linear binomial with no coefficient or exponent. This is a much faster way, which gives us the same answer. Our first example we did was this. And it equaled x plus 3. That's the first one we did. So I'm going to do the same one, but this time I'm going to use synthetic division. So there's my original question. First step, solve the bottom. Yeah, so x plus 2 equals 0, so x equals -2. Because in synthetic division, we only use numbers. There are no letters. So -2 goes outside of our dividing thing. Remember, in this way here, our equation looked like this, right? We had the x's and the numbers and everything. But since I'm not using any more x's here, I can't use the same symbol. So in synthetic division, you use that symbol. Whenever you see that, then you know it's synthetic division. There are no variables in the equation. Only the coefficients. So in this first column, start with the highest exponent. So I like to label, since my first highest exponent is x squared, then the next one's x, the next one's constant. Those are the columns. What's the coefficient of x squared? Coefficient of x and the constant. So everybody okay setting it up? If not, we're going to do another one anyway. So in synthetic division, it only involves multiplication and addition. This row here is the resultant row. So we start off with nothing here. When you go up and down, that direction is always addition. So 1 plus 0 equals 1. So now we need the next box, the next space. That's where this one comes in. This is the multiplication. Whatever's out here times whatever's on the bottom. -2 times 1 is -2. Remember, up and down you add, so it's 5 minus 2 is 3. And whatever's down here, you multiply with what's on the outside. So -2 times 3 is -6. Yes.
So does the first column always start with 0?
Yes, because there's nothing there. Remember, these other numbers come with this times this. There's nothing here, so -2 times 0 is 0. So now we add 6 minus 6 is 0. This last number is your remainder. And these, the 1 and the 3, are the coefficients of your answer. The last one's the constant, the next one's the x, and it builds up from there further. So our answer is 1x plus 3, or x plus 3. Let's try another. What's my first step? Solve the bottom. Gives me what? So -3 goes on the outside. So my highest exponent is x cubed, I need an x squared, an x, and a constant. So what numbers go inside the first one? Next one? Third? -5. And then a -6. Remember, all we're using are the coefficients. The signs go with the numbers. There's a 0 in the first one. Yeah, so this number out here only multiplies to those numbers on the bottom. Give me the next number. So -3 times 1 is -3. 2 plus -3 is -1. -3 times -1 is +3. -5 plus 3 is -2. -3 times -2 is +6. So is x plus 3 a factor? Yes, because remainder is 0. So what's the rest of the polynomial I have left? Nope, because we started with x cubed, right? And we divided by x. So whenever you take 3 divided by x cubed divided by x, you always end up with 1 less. So this one's going to be x squared minus x minus 2. Now, the beautiful thing about synthetic division, see all the space I have left? That's all I need. Remember when setting it up, start with the highest, and you have to go down from there. So the coefficient of x to the fourth is 1. Coefficient of x third? Yeah, it's not there, so it's 0. X squared, x, and then constant. Very good. Remainder 0. So it's a factor. Then what's remaining with the answer is, so it's always one less than what you start off with. So it's x cubed plus 5x squared minus 1x minus 5. A lot faster, isn't it, than long division? But you have to know how to do long division in case the denominator has a coefficient or an exponent. So if you're given the equation of the denominator, asking is this a factor? You have to solve it and do that. But originally, the question was, is 5 a 0 of that polynomial? If you're given the question like this, is 5 a 0 this polynomial? Just use that number. And then what we've done already. You only have to solve for 0 if it has an x in the equation. If I just give you a number, just plug it in. Just use it. Okay, what's on cover? Oh. Finding missing zeros. We have to do these two as well. How to find missing zeros, and then how to find the polynomial if I give you the zeros. Let's do this one first. Let's work it backwards. Let's look at what's going to happen here. In the past, I gave you the polynomial. We factored it out. We got x plus 2, x plus 3. Then what do we do? It equals 0. Then we take both of these and set them equal to 0. And then we solve them. So these are my zeros. Everybody remember that? Now we're going to work backwards. If the zeros are 2 and -5, find the polynomial it came from. So what we begin with, we're given the zeros. So we know x equals 2 and x equals -5. We're right here. We're going backwards. We're going this way. So set these equal to 0. So this one is x minus 2 equals 0. This one is x plus 5 equals 0. Since they equal 0, if I multiplied both of them together, it should also equal 0. Now we just multiply. X times x is x squared. X times +5 is +5x. -2 times x, -x. -2, 5 is -10. Combine like terms. 5 minus 2 is 3. There's your polynomial. So just work backwards. Find the polynomial if the zeros are, which one do I use? X minus 1, x minus 3i, x plus 3i. So what's the degree of my polynomial? Nope. Remember, so far my polynomial factors out into x minus 1, x minus 3i, x plus 3i. How many x's do we have? X times x times x is x cubed, degree 3. Since we have 3 solutions, that's the number of degrees. Now, if we had more time, we'd multiply these out. But the important part of this one, I want you to notice, whenever you have imaginary numbers, they always have to come in conjugate pairs. Because if we multiply these two together, we get x plus 9, or x squared plus 9. Again, you could FOIL them out. It was negative 3i times negative 3i is, no, negative times positive is negative 9i squared. What does the I squared do? It's negative 1. It changes the sign of the term in front of it. Again, review the section in section 2, chapter 2 on imaginary numbers. And we multiply those out. So whenever you have imaginaries or radicals, they must have a conjugate pair. Remember what a conjugate pair is? All you do is change the sign in front of that operation. So if we had the following zeros, what is the degree of the polynomial? I have to make sure the door next door is closed. Because I went in there earlier today to check out the computers. I heard some noise back there. So these are my zeros. What's my degree? Why? Very good. The degree is 6. Because there's 1, 2, 3. We're missing which ones? Very good. Very good. There's our 6 answers. So it's always possible to have a radical or imaginary as an answer. And if you do, they always come in pairs. So remember, our whole objective is try to find what are the factors, what are the solutions of any polynomial. How do we do that? Well, we find out what factors, what divides in there, what gives us a remainder of 0. Now, if I give you this equation, this is polynomial x. How would you decide where to start finding solutions? We could start dividing x plus 1, x minus 1, x plus 2, x minus 2. Keep on going. How many possibilities are there? Well, they can also be fractions. So there's pretty much an infinite number of chances you can do. This next part, we'll start narrowing it down. We'll come back to this in a second. Let's look at the ones we've done already. This is called the Rational Zero Theorem. Remember, every number is a rational number. 5 is a rational number, 5 over 1. So every number is a rational number. If the rational number P over Q is a 0 of P of X, then X minus P over Q is a factor of P of X. In about 10 minutes. Yes. How long of a break you need? Okay. Okay, yeah, come back in about 5 minutes. We'll try to finish up. So if we have a rational number and it's 0, that means X minus that number is a factor. That's the stuff we've been doing all along. The question is, what are P and Q? P is the constant number, and Q is the leading coefficient. So in this case, that number there is my Q. What is that? It's 1. This number here is my P. So what the rational zero theorem tells us is this. The possible solutions are P over Q, which is 6 over 1. Do we know if they're positive or negative yet? No. So we have to take the positives and negatives of those. But one more thing, it's not always just one number. We're supposed to have 2 numbers. So what we do, what are the factors of 6? What are the factors of the top and the factors of the bottom? One, 3, and 6. Of course, 1 times 6 is 6. -1, -6 is 6. Oh, I forgot a 2. 2 times 3 is 6. So 1, 2, 3, and 6 are all factors. And the bottom, we just have that 1. So let's look at all the possible rational factors. Since we only have one denominator, we take each of these. We have plus or minus 1 over 1, plus or minus 2 over 1, plus or minus 3 over 1, and plus or minus 6 over 1. We took each of these numbers on top, divided by that number. So 1 divided by 1 is 1, 2 divided by 1 is 2. So these are my possible answers. I've taken an infinite number of possibilities and narrowed it down to these 8. Why is it 8? Yeah, because we have one number on the bottom times 4 numbers on top and times the plus or minus. So there's positive, the answer is going to be positive 1, negative 1, positive 2, negative 2, positive 3, negative 3, positive 6, negative 6. So I would just go ahead and start doing synthetic division. Start doing synthetic division and see which ones will work. We only need 2 of them. Does that make sense? So that's the rational zero theorem. Let's go back to this one. Tell me the rational, give me the possible zeros, the rational zeros of this equation. I'm sorry, you couldn't see that, could you? Remember, the leading coefficient is Q, the constant is P. So the factors of 4 are 1 and 4 or 2 and 2. So 1, 2, and 4. The factors of 3 is just 1 and 3. How many possible answers do we have? We have 2 numbers on the bottom, 3 numbers on top. That's 6 times the plus and minus. We have 12 possibilities. What are they? So here's our first denominator. 1 over 1, 2 over 1, 4 over 1. Then the 3. 1 over 3, 2 over 3, and 4 over 3. Those are them. Make sense? So now all you have to do is start plugging these numbers into your synthetic division and see which ones give you 0. So that narrows it down first. There's another method Descartes' rule of signs. Remember Descartes? Descartes. He's the one who invented the X and Y axis, the Cartesian coordinate system. That's him. He's back to visit us. What he said is the number of sign changes tell us the possible number of positive answers and negative answers. So let's look at the one we just had on top. 3x to the fourth, 11x cubed, 10x minus 4. So the number of positive solutions use the original equation. So what I'm saying here is, look at the coefficients. Do they change from positive, negative, negative to positive? So this one's positive to negative. Is that a change? Yes, that's one change. From negative to positive, that's a change. From positive to negative, that's a change. So we have how many changes? So we can have 3 positive answers or 1 positive answer. This is important. Always subtract by 2. Why? If I had 7, then I'd have 7 or 5 or 3 or 1. Why do I subtract by 2 each time? Think of conjugate pairs. If the answer is imaginary, it has to have its conjugate pairs. So we lose 2 possible answers. So we can have 3 or 1 positive answers. So far, so good? Because it's the number of sign changes. Whatever we have here, can you subtract by 2? There's your possibilities. Number of negative solutions. Here, I got to put a negative x in there. So anywhere I see an x, I put a negative x. So anywhere I see an x, I put a negative x. Now, here's the only thing you have to worry about. If the exponent is even, don't worry about it, because negative number to an even power is positive. So that's not going to do anything. So that one's not going to change. If it's an odd exponent, then that negative inside the parenthesis multiplies to the coefficient sign. So a negative times negative is a positive. A negative times a positive is a negative. Whereas here, only change the sign of the coefficient with odd exponent. So if you have an odd exponent, just change this chain coefficient. Now let's look at the signs. Positive and positive, nope. Positive to negative, yep. Negative to negative. We will have one negative answer. Because you can't subtract 1 by 2. Well, actually, once you let's do another one real quick. Let's look at this one. This one's pretty big, which I wanted to do. And the negative one. So for the negative one, all you have to do here is anywhere you see an odd exponent, change the sign in front of it. So I got to change that sign and that sign. Because a negative x only changes odd exponents. Everybody follow that? Or is it too confusing? Because a negative 2 to the third power is -2 times -2 times -2. The answer is going to be negative. If you have an odd power with a negative, it's going to be negative. So when you do this, just change the signs of any x that has an odd exponent. That's all you have to do. Don't worry about the even ones. Positive solutions. There's one sign change from positive to negative. Then from negative to positive, that's another sign change. From positive to negative. From negative to positive. So there's 4 sign changes, which means what? We can have 4 or 2 or 0 positive answers. Because I subtract 2 each time. Positive to positive, positive to positive, positive to positive, positive to positive. So I know I'm not going to have any negative solutions. It goes into more details in the videos I sent y'all last week. But yeah, I wanted to cover those because that's the last part of section 4. This is as difficult as it gets. From here on out, it's downhill. And I'm sorry I sped in this last one because it was the most important, but we're running out of time. Think about it. Next week is Thanksgiving. However far we get next Tuesday, that's what the final exam is going to be over. So we got tons to do. All right, if you haven't